So first of all, it's a quadratic equation in vertex form, or a quadratic function, we should say. One way I know this is a function is because it's set equal to y, and then all of a sudden I have a domain and a range. And so this is something that I can graph. So anyways, to find out where that vertex is, and if you remember in the last lesson, the vertex is the point where the parabola bends. It's either the maximum point or the minimum point. And so when the equation's written in this form, we call this number right here h, and this number at the end k. And what's important about this is notice h is always the opposite of whatever this is. So you can tell from the formula here that minus h. So notice that h is always opposite of the number in the function, and that k will be exactly as it appears in the equation. This will make more sense here in a little bit when I give you an example. Let me go ahead and read the key point for today. When a quadratic function is written in vertex form, it is easier to determine the vertex of the parabola. Once you identify the vertex, select x values on both sides of the function. Make a table of the domain and range values to identify 5 points to the function. Then graph the function by plotting the points and drawing a smooth curve through the points. Okay, so here's an example, and this kind of is going to take a step through step what's going to happen here. So you're going to be given a function that's in this form, y equals the opposite of x plus 2 squared plus 3. So the first thing you're going to look at is the 2 and the 3. Now we just learned that the vertex is the opposite of this number and exactly the same k value. So our vertex would be negative 2, 3. So when I'm deciding on what points to put in for x to solve, I would already know that I want to use the negative 2, 3. Now, parabolas are symmetrical. So if I pick a point on the right side, I want to pick the same distance from the vertex on the left side, and vice versa. So the way I would do that is I would identify 2 points that are smaller than the vertex x value and 2 values that are larger, negative 1 and 0. So that's the second step here. Select 2 integers smaller than the larger than the x-coordinate of the vertex. So in this case, negative 4, negative 3, negative 1, and 0. Third, make a table by solving the function for the x values determined in the second step. So in the table, you'll plug these numbers into the equation, into the formula, and you'll find out what y equals. This is kind of a tedious process. You got to keep plugging the number in for x and then figure out what y equals. So the negative 4, negative 1, that's a solution. So we'd plot it over here on the graph. Negative 3, negative 3, positive 2 is a solution. We already determined our vertex. Notice that these points, if you pick an integer that's both larger than the vertex and smaller than the vertex, that's only 1 unit away, then you're going to get points that are plotted that are across from each other. And then the last point here is 0, negative 1. Once you have the points plotted, you're able to draw a curve through these points. Now, this parabola opened downwards, and if you remember, we talked about this before. Because there was a negative in front of the parentheses, that's what caused the parabola to open downwards. So I want to look at some slides here. Just first of all, this is the vertex form of a parabola. This slide here shows that the opposite of h and k will show you the vertex of that parabola. This slide here, again, points out that this is going to, what happens is there begins to develop a pattern to this. So you're going to see a pattern that this means to move the parabola to the horizontally, and this is going to cause the parabola to move up vertically. And then we're going to look at A here to determine whether it opens upwards or downwards. And it's saying if that number is greater than 1, it actually makes the parabola skinnier. And if it's between 0 and 1, it makes it wider.